All right, good morning, guys. It is Friday, January the 11th, and I'm wanting to go ahead and get back to doing some videos for y'all so that y'all can use for when you're studying. Want to talk about the sum and difference of cubes. Want to just give you some extra material on that. So if you give me a minute, let me set this to the side. I'm going to write down those forms. So a plus b, x squared minus ab plus b squared. All right, there we go. All right, so these are the two forms for sum and difference of cubes. The way to tell it which one you should use, if you look at the first binomials, if you're talking about a sum of cubes, it'll be the one with the plus, and you'll notice that'll have a minus in the middle term on that trinomial. If it's a difference of cubes, the first one will be a minus, and the middle term will be a positive. So there's a way you can tell. Now, when you're looking at a problem like this number 2, real quick, number 2, it has an a to the third. I know if I take the cube root of that, I get a. If I take the cube root of 64, it's going to be 4. No, yes, 4. But the fact is that plus right there, that tells you which one you're using. Okay? Now, let's work a couple of these problems out. So I'm looking at number 1 here. I look at it and I see the x cubed is a perfect cube. If I take the cube root of x cubed, I get x. So my a value is going to be x. The 125, if I take the cube root of it, it's going to be 5. So my b value is 5. Don't mistake and say that the b is 125. No, it's not. The b being raised to the third power is 125. So now that I have my a and b values, I can actually apply that form. So here's what I'm going to do. I'm actually going to write the form out again. I'm going to rewrite it again, but I'm going to plug it in right below it so you can kind of see what's going where. So everywhere I see an x, I'm sorry, I said that wrong. Wherever I see an a, I'm going to put an x in its place. So okay. Then I'm going to go back, and everywhere I see a b, I'm going to put a 5 in its place. So I've got a plus 5. And I went ahead and put parentheses where the b's would go. So now it becomes a matter of plugging in the correct, simplifying them correctly. Now, take note of what I did. Notice how I put parentheses, like where the a squared is. Notice how I put parentheses and put a squared, and then I put what the a value was inside the parentheses. I don't want you to overlook that. I want you to pay attention to that, because sometimes it may not just be a variable like for the a value. For instance, just real quick, if that had been 8x cubed, well, then my a value would have been 2x, and I would have had to put 2x inside of here. So you need to be mindful of these small things. Conceptually, people get this stuff overall, but it's those details that just kill everybody. So pay attention to what you're doing. So I have x plus 5. In that one, I have x squared minus 5x plus 25. And you're done. That is a sum of cubes. Now let's look at a difference of cubes. So I did not mention this earlier, but I'm going to go ahead and mention it now. Do I have a GCF? Question. The answer would be no in this case, right? But on the previous one, I should have led off with that. You need to check for a GCF always first. So I don't have one, but this time it's a difference of cubes. So cube root of x cubed, my a value is going to be x. My b value is going to be 4, because the cube root of 64 is 4. Think of that like saying 4 times 4 times 4. 4 times 4 is 16. Times 4 is 64. Man, this thing's shifty. Okay, so again, I'm just going to write that form out for you. Writing that for you. All right, now we plug them into the proper spot. So I got, in the first one, I got, I got x minus 4. And there it is. You're done. Okay, so I hope those two, as far as sum and difference of cubes, I mean that's pretty much the gist of it. I mean, I could go look at some really weird problems, but that's pretty much the gist of them. Now, what I did want to talk about briefly is some of the sum and difference of squares. So this is actually one of your homework page. Well, yes, it is your homework page. So if we go back up here and we look at differences of squares, if we remember, the form for that was a plus b and a minus b. Okay? So you just need to know that. And you need to know why it works. Think about it. If I take a times a, if I'm pulling it out, in other words, I get a squared. If I multiply the outers, I get a negative ab. If I multiply the inners, I get a positive ab. Well, negative ab plus ab is 0. I don't see an ab nowhere in the middle here, do I? And if I multiply the last terms, b times a negative b, I get a negative b squared. That's how this is coming about. Now, let's take a look at this. So, just going back here for a minute. If I want to know what my a value is, see right here it's saying a squared. If I take the square root of a squared, that's going to give me my a values. If I take the square root of b squared, that'll give me my 2b values. Because remember, square root is like for instance, if I say good Lord, if I can get my paper to cooperate. If I say the square root of 4, that's like saying what number multiplied by itself twice gives me 4. Well, it does. 2 times 2, right? So it's 2. Now, let's look at this one. So I'm asking myself, all right, if I take the square root of x to the 4th, what am I going to get? It's going to be x squared. It basically just takes that and cuts it in half, if you want to think of it that way, just for the time being anyway. So my a value is x squared. All right, look at this one. Can I take the square root of 36? Yes. The square root of 36 is 6. So my b value is 6. So my factored form is going to be x squared plus 6, x squared minus 6. Now, as a precaution, you don't just simply, especially when you see like an even degree and something like this, you don't just circle it and say you're done. You might not be. X squared minus 6. Okay, so here we particularly look at the minus because a difference of squares thing could come about. So x squared, I can take the square root of it and I would get x. But can I take the square root of 6? Well, the answer to that's no. No, you can't. So I can't get a perfect square out of that. That's how I know that I'm finished. The reason I don't worry with this one is this one right here. If you remember, the end game to all this is that eventually I'm finding roots and all this. This actually will end up giving me an imaginary, actually 2 complex roots. So that's why I don't mess with that. But this right here is finished. Let me do one more with you. So let's look at number 9 here. So number 9, let's see, 3 and 48. Do I have a GCF? And the answer to that would obviously be yeah. So I can pull a 3 out of this, which is going to leave me this inside. I'm going to have m to the 4th minus 16 n squared. 3 times 16 is 48, by the way. The m to the fourth, n squared, obviously they're not in the GCF because they're not even the same variable. So now I'm looking at this, okay? Give me a second to reposition. I hope y'all are not like you don't get like motion sickness real easy. I look at this and I say, all right, m to the fourth. Can I take the square root of m to the fourth? And the answer is yes, it's m squared. So your a value is m squared. 16 n to the second, what can that give me? Well, 16 in the second can give me 4n. So from here, I can write my two binomials. I can say m squared plus 4n, m squared minus 4n. That 3 that I pulled out, it goes just right there to the left. This one is done because I can't take the square root of 4n. The n would still be under a radical if I did that. So that's how I know I'm done. So I will end it there. Hope this helps you guys. And if you have any questions, bring them to me.